Module 1, the course is web development. Module 1 says concepts in web development. Now, for everything you do that has a technical side to it, there are always concepts that guide, the activities in that field. In web development, there are many concepts that will help us understand what developers do when they develop websites or when they develop applications that run on the web. And that is what we're going to be looking at in Module 1, which says Concepts in Web Development. We'll be looking at foundational principles, we'll look at architectures, and then best practices for building modern web applications. What are we supposed to learn in this module? By the time we're done with this module, we will be able to define web development and we will be able to distinguish, that's differentiate between front end, back end, and full stack development. Two, we will be able to explain the client server model and how HTTP facilitates communication on the web. Three, we should be able to understand the roles of HTML, CSS, and JavaScript in web page construction. Four, we will be able to describe the software development lifecycle as it applies to web projects. And then we should be able to apply basic principles of responsive design and web accessibility. So, Module 1 is packed full of learning objectives, five of them. So, let's dive in and see how we can begin to tackle these five objectives. The first one says we should be able to define web development and then distinguish between front end, back end, and full stack development. So, let's see how we can do that. Number one, introduction to web development. Now, what is web development? Web development is the process of building and maintaining websites and web applications that run in a web browser. It encompasses everything from simple static pages to complex data driven platforms. Practitioners are typically categorized by their area of focus. Now, let's break this paragraph down, this definition down. First, it says web development is the process of building and maintaining. So, web development has to do with two key activities. Number one is to build, number two is to maintain. When you build web applications or websites, you also need to maintain them. And what this means is sometimes you need to introduce changes, sometimes things may not work well and you need to uh, upgrade the version. Sometimes modern trends change and you'd love to catch up with the trend, so you need to make changes. So the two things you primarily do is you build. After you build, you maintain the websites to make sure that the attention, to make sure that your customers are always kept satisfied, and to make sure that you are following the changing trend in modern development. So again, let's remember that two things that we need to do for web development in defining web development is building and maintaining. Now, what do we build and what do we maintain? We build websites and web applications. If you're asking questions as to what is the difference between a website and a web application, now the website is a group of pages, a group of web pages that work together. A website is a group of web pages, that work together. They form a complete system. They work together. But a web application is a part of that website that helps you to complete a task. It's a part of the website that helps you to solve a problem. So let's think about a website as a huge house that has a kitchen area. That huge house has a sitting room. That huge house has like three bedrooms in it. The huge house has, a garden somewhere outside. So that's how a website works. A website is like a huge house that has many different sections. So the different web pages, are going to be the ones that present the different sections. So where are the applications in a website? I'll give you an example of an application in a website. When you visit the CNN website, for example, you will find, an option to sign up. You find an option to sign up. That part of the CNN website is actually an application that helps someone to sign up. And then after signing up, when you visit the website again, you find a form that asks you to log in. So that is a small application in the whole of the CNN website. Now, sometimes when you finish reading an article, you may find that at the bottom you are encouraged to make comments. That part is also a small kind of application that collects data. So, applications are small systems within websites that help the users to complete tasks. So, there is a difference between a website and a web application. A single website can have as many as 10 different applications working within it. So this is the definition of a website. Again, it says, sorry, this is the definition of web development. It says web development is the process of building and maintaining. What do we build and what do we maintain? Websites and web applications that run in a web browser. Now, the last part of this definition brings us to talk about platform. When we build applications, we build applications for particular platforms. We build applications so that they can run on particular platforms. You can build an application that runs on a Windows laptop. You can build an application that runs on a Mac laptop. You can build an application that runs on a mobile device. You can also build applications that run on Android mobile devices or just iPhones. And here we are talking about web development, meaning building applications that run on web browsers, that run in a web browser. So the platform is the web browser. So this is the definition of web development. All right, let's move on to talk about some other concepts in web development. Now, in web development, there is the part that we see, and then there is the part we don't really see. Yes, there's the part that we can see. When you visit the website, you see the pages, you see the beautiful pages, you see the text on the pages, you see the images, the videos, and all of that. Now, that is the part we refer to as the front end. So, the front end is the engaging part of a website that the users can see and interact with. So, let's just look at what it says here. It says front end is concerned with the visual, the user facing portion of a website. Technologies, for building front end include HTML, CSS, and JavaScript. And HTML is used to structure the website, CSS is used to style the website, and JavaScript is used to engender interactivity. Now, if you're wondering what HTML and CSS mean, HTML means hypertext markup language. Hypertext markup language, while CSS means cascading style sheet. Cascading style sheet. So for front end development, that is for the interface that we see when we visit a website, there are primarily three technologies used to create that: HTML, CSS, and JavaScript. Now, sometimes to make the work of the developer very easy and fast, there are frameworks, that have been built and they are much more advanced than the ordinary JavaScript. For example, we have React, we have Vue, we have Angular. These are streamlined to make front end development very fast, very interactive, and very effective. Now we move on to back end development. Back-end development actually is the part of an application or a website that we cannot see. We don't know what's really going on there. And the back-end actually is the engine. It's the part of the website that deals with the data. It's the part of the website that makes the website actually function. So here it says it handles server-side logic. It handles databases, it handles application programming interfaces. We'll get to talk about these things more when we begin to get involved in practical exercises. So the back end is just like the engine of a car. If you're driving a car, you sit in the driver's seat, you hold the steering, people see the beauty of the car, but they don't actually see what is happening inside of the engine. So the back end is like the engine of a website where the data you submit is taken, it is processed, and then a value is returned. Imagine how a calculator works. You type in 1 plus 1, you press, the equal to sign, and then it returns the value 2. So how is it able to do that? You cannot observe the process. That process is being handled by an engine or by backend where we cannot actually access. So backend development has to do with the part of a website we cannot see that handles the server side logic, the databases. Databases are meant for storing the data of users. That's what databases are meant for. And then an application programming interface. We call them APIs. Now, what else does backend development have to do? Backend development works with languages like Python, Node.js, Java, PHP, and Ruby. Now, when we talked about front end development, we mentioned the technologies used to create front end development. We talked about HTML, CSS, and JavaScript. Now, in back end development as well, there are some languages that are suitable for writing our code. Now, these languages, Python, Node.js, Java, PHP, and Ruby, are much more powerful than HTML, CSS, and JavaScript. Of course, we know that Node.js has this very strong connection with JavaScript, but it's now operating at a level higher than ordinary JavaScript. So languages like Python, Node.js, Java, PHP, Ruby, C++, C, they have the ability to interact with our systems, with our computers. They have the ability to read files in our computers. They have the ability to delete files. They have the ability to create files. They have the ability to create folders and directories. They have the ability to do lots of things. So that is why they actually work at the back end. And at the back end, that is where you have to save data. You have to do a lot of things. So for backend development, we will use languages like Python, Node.js, Java, PHP, Ruby, even other languages like C, C++, and C Sharp. Now, backend development is also responsible for authentication. It's responsible for data processing and business logic. These are some of the things I just talked about. If you have registered on a website and let's say a week later you want to access your data on the website, you will be asked to log in. So the back end is responsible for checking whether your password is correct and your username is correct. That's the authentication part. And then we have data processing. The back end is also responsible for processing your data. If you want to update your CV, for example, to um, your account on a website, it is the back end that is going to take the update and replace the old one with the new one. And then business logic as well is there. So we've talked about front end development, back end development. Let's talk about full stack development. Let's quickly talk about full stack development. What is full stack development?
Please excuse me, sir. I've not finished writing the other one.
You don't need to write. I'm going to share the file with you. So please, you don't need to write. I'm going to share the file with you. You don't need to write. You can just jot one or two things. Don't write the whole thing. So full stack development has to do with, front end and back end at the same time. There are people who concentrate on developing the front end, and there are some other people who concentrate on developing the back end so that the work is not too much. But there are others who can develop the front end and the back end at the same time. They do it at the same time. So full stack development has to do with front end and back end. Now, full stack developers can build end to end web solutions independently. They won't have to depend on someone else to design the UI for them or someone else to create database schemas for them. They can create the front end, they can also design the back end. So these are the kinds of people we refer to as full stack developers. Now, popular stacks. Okay, what we mean by stacks here is the different technologies that we can use to build a website. So popular stacks, we have MERN, which is which encompasses MongoDB, Express, React, and Node.js. And we have LAMP. We also have one that we call WAMP. So these have to do with different technologies. These have to do with different technologies. Now, there's a technology that works with PHP, MySQL, JavaScript. Yes, PHP, MySQL, JavaScript. So we have different combination of technologies that will allow us to build websites. For example, if you want to use Python, you would be using Flask as well. Flask and Python form one stack that you can use to build your websites. All right, let's see how we can accelerate so that we can at least cover the first module today. Now, we're going to talk about another concept, the client server model. The client server model. The client server model is the foundational architecture of the web. A client, typically a web browser, sends requests over the internet to a server, which processes those requests and returns responses. This communication relies primarily on the hypertext transfer protocol. Now, that's the meaning of HTTP. So let's think about the client server model this way. I am sitting down here in my room with my computer connected to the internet. I am going to search for something on the web. And then there is another computer in the USA that has all the files that I need. So what I do is I start my browser, I go into uh, the search box, and I type what I need. So once I do that, I become the client. Sorry, my browser becomes the client. It is the client that sends the message, to the internet. So when I do that, I am sending a message, and uh, it's actually called the protocol that handles that is actually called the hypertext transfer protocol. So my message is carried and sent to the internet, and then there is a server that is going to respond. For example, the server in the US that has the files that I want is going to respond if it has my files. So my browser will be the client, and then the computer that has the files that I want is going to be the server. Now, both computers have to be connected to the internet. This is not something you can do if you're not connected to the internet. Although you can set up offline server client relationships, but basically, this works on the internet. So, the internet server will process my request and then it will return a response. So if it has the files that I've requested for, it is going to return them. If it doesn't have the files, it's going to respond as well, but it won't be able to return the files. So let's take note of this. HTTP means hypertext transfer protocol. Now HTTP is a stateless request response protocol. Common HTTP methods include GET and POST. We also have PUT and DELETE. GET means to retrieve data, POST means to submit data, PUT means to update data, and DELETE means to remove data. Responses from a web server can carry status codes such as 200, which means OK. So if I send an HTTP request to a server and that server has the data that I want, it's going to send back to me a response code of 200, which means OK. If it doesn't have what I want, its response code is going to be 404, which is not found. And if there's a problem with the server, it's going to return 500. So we have what we call status codes. Status codes that the server can send back if the request is okay, if the request, if what has been requested is not found, and if there is a problem with the server. Now we're going to move on to responsive design and accessibility. I've already told us that we're going to spend like 2, 3 weeks talking about the concepts, and then from probably the third or the fourth week, we'll begin to execute our project. So there is what we call responsive design. There's what we call design. Responsive design has to do with your web page behaving as expected, whether it's on a mobile device, whether it's on a laptop, whether or it's on a tablet. So wherever your web page is displayed, it has to behave as expected. It has to be presentable. So that is what we are going to talk about: responsive design. We're talking about responsive design now. So responsive design ensures that a website adapts its layout and content to fit different screen sizes from desktop monitors to mobile phones. Yes, from desktop monitors to mobile phones. Now, CSS media queries, flexible grids, and fluid images are core tools for achieving responsiveness. You can visit the same website on your mobile device, on your laptop, and then you know that the screen size of your mobile device is smaller than that of your laptop. So how is it that the website, is still being presented uh, in a very in a very good way, in a way that does not disrupt the content of the website? It is because that the website was designed with responsiveness. So responsive design was applied in creating the website. We'll also talk about that. We'll implement that when we start a project. And then web accessibility, often abbreviated as A11Y, ensures that websites are usable by people with disabilities. Guidelines are provided by the Web Content Accessibility Guidelines. Key practices include providing alt text for images, ensuring keyboard navigability, and maintaining sufficient color contrast. Let's move on. Now, the last part, I think this is the last part here. All right, this is the last part. The last part here, we'll talk about software development lifecycle. Now, this is very, very important for anyone who wants to create a software. The software development lifecycle. It provides a structured process for planning, creating, testing, and deploying web applications. Common models include waterfall, agile, and scrum. Agile methodologies, which emphasize iterative development and collaboration, are dominant in modern web projects. Let's quickly talk about this very briefly. Now, when you want to create an application, whether it's a web application, a website, or a desktop application or a mobile application, there is a process that enables these, um, yes, that enables the development to be seamless, to be fast, and to be reasonable. It is called the software development lifecycle. There are several stages involved. In some discussions, you'd find that there are 7 stages. In some, you'd find 6 stages. In some, you find 8 stages. But altogether, the concepts remain the same. So the first thing you need to do is you need to plan your application. In planning your application, you work out the name of the application. You look at things like logo. You look at things like what your application is going to do, the problem your application is going to solve, the platform where your application is going to run, who you are building the application for, what technologies are you going to use to build the application, how is your application going to look like. You're going to provide mock-ups and wireframes that will represent the way the application is supposed to look like. Then we'll have the implementation stage, we have the testing stage, and then we have the deployment stage. So this is what we refer to as the SDLC, the software development life cycle. Now, key phases include requirements gathering, design, implementation, which means coding. After you've gathered the requirements, for example, you have said that our application should have a text box where people can type in comments. Application should have a button that sends the comment. Application should have this and that. So these are the requirements gathering. Then somebody is now going to design that, probably with an image editor. It's going to design that with a graphic uh, editing software, probably Corel Draw, Figma Online. So after one of the team members have designed that, those who are going to write the code will now have a visual, you know, documentation of what they are going to create. So they will be the ones to implement the design by writing code. After they write code, there are others who will test to make sure that the code they've written is working. So after everything has been done, the testing phase is over, the application can now be deployed. All right. You remember when we defined website development? We talked about two crucial activities: building and maintaining. And here you can see the last step is maintenance. After you have built, you must maintain. Now, version control systems such as Git are essential throughout all phases to track changes and collaborate effectively. So, this is the end of module one. We won't be able to talk about module two now, so we'll have to wait till next week. Hopefully, next week we'll be able to talk about modules two and three at the same time. So, I'm going to stop here so that we can ask questions and then we can do other things. Yes, please, let's go ahead and ask questions. Or maybe I should ask my questions first. All right, I think I'm going to ask questions first.